Welcome to video number 13 on digital communications, part of the West Desert Amateur Radio Club's Technician Class License Exam Preparation course. Just as a lot of technology is going digital, so is amateur radio. Of course, when radio was first put to use, the communications mode was Morse code, the original digital mode. All digital modes have in common that symbols are transmitted rather than analog voice. Morse code is still a very popular communications mode, and there are more Morse code operators than ever before on the radio waves. I have a straight key, which is very much like the original telegraph key. Most of my operations, however, is with a paddle, an electronic keyer. This is my paddle. It's a two-lever paddle. There are also single-lever paddles. With my paddle, pushing the left paddle to the right with the thumb sends dots for as long as I hold the paddle to the right. When I push the right paddle with my index finger to the left, it sends dashes as long as the paddle is held in that position. Squeezing the paddles together causes it to send alternating dots and dashes. It's a very convenient method of sending Morse code. For almost all other digital communications modes, a computer is interfaced to the transceiver by way of the computer's sound card. The signal is sent from the computer's speaker output to the transceiver's microphone input, and the received signal comes from the transceiver speaker output back to the computer's line or microphone input. There are specially made inexpensive amateur radio sound cards that plug into a USB port, which not only isolate the computer from the transceiver, but also generate the push-to-talk signal to switch the transceiver from receive mode into transmit mode. Modern transceivers also have a data interface built into the radio to facilitate digital communications. So the computer is connected to a sound card interface, which is connected to the transceiver. The computer generates the desired signal, sends it to the transceiver, which transmits the modulated signal. The received signal is sent back to the computer to be decoded and viewed on the computer screen. There are a number of digital modes available for amateur radio operators, and many of them are designed to be used on VHF and higher frequencies. You'll need a multi-mode radio for some of these digital modes, as they are sent over single sideband emissions. There are also some that are sent over FM emissions, but you'll probably need a base station rather than a handheld radio to use them. Packet radio was invented in the 1960s, and the modern internet was derived from packet radio. Packet is used even today as a reliable message handling system. Recently, PSK, phase shift keying, JT65, FT4, and FT8 have become available. These are very narrow signals and can often be received and decoded even when the human ear can't hear the signal. JT65 was developed for moon-bound communications. Prior to JT65, the ham radio operator needed a very powerful station with very efficient antennas to get enough signal to the moon that it could be heard by the receiver. JT65, however, is a weak signal mode that transmits information very slowly with many repeats, and now just about any amateur radio operator can use JT65 to make Earth-Moon-Earth contacts. Joe Taylor, K1JT, and that's where the JT from JT65 comes from. Joe Taylor, K1JT, a Nobel laureate physicist and ham radio enthusiast at Princeton University, has led a team of scientists doing work on very weak signal handling. They've developed FT4 and FT8, transmission modes that require a good computer to decode, as the signals may not be discernible otherwise. Some of the transmission modes include forward error correction, automatic repeat requests, ARQ, header information containing information about the transmission, and schemes to provide highly reliable communications. Radio waves emitted from an antenna may be reflected off of other objects or buildings, and the same signal may arrive at the receiver from different directions and at different times. This is called multipath. The human ear can usually decode those echoing signals. Digital modes, however, are very susceptible to multipath signals, and it can definitely degrade reception and increase error rates. I've heard myself on occasion on HF. My dipole antennas transmit equally well both east and west. Sometimes the signal travels all the way around the world and comes back about 2 seconds later to my radio. It is a bit eerie to hear yourself. Automatic packet reporting systems were developed initially as a means of automatically sending position information and short messages between vehicles on the move. It has since evolved into a wide variety of applications. For instance, many amateur radio operators connect a weather station to an APRS transmitter. The U.S. Weather Service uses this information to assist in their forecast development. There are thousands of APRS weather stations in the Intermountain West alone. APRS is also used when supporting competitive events. The real-time location of participants is readily available. The Salt Flats Endurance Run, for instance, equips a few runners with APRS transmitters that include a GPS and can see the location of the runners as they move across the desert in this 2-day event. I have an APRS unit in my car. It transmits by location when I'm driving. The updates are sent every 2 minutes or whenever I make a turn 25 degrees or more. When we're on our way to visit some of our family, the grandkids can readily see where we are and about when we'll arrive. This system has been so popular and useful that the trucking industry copied the capability and they run it on commercial frequencies. Of course, the amateur radio version is free. Trucks pay a fee to use their system. So here's a picture from APRS of my route a few weeks ago. This covered my entire route from Tooele to Bountiful and then to a cemetery in Salt Lake and then back home. The database behind the APRS.FI website will keep this historical information for about 5 years. There are also digital voice systems. Digital voice has some nice advantages over analog voice. The voice is much clearer, there's no static, and the signal doesn't get weaker the further away from the receiving station it is. That is until the boundary is reached and the signal just stops. There is no fade. The original digital voice was developed in Japan and is called D-Star. In addition to voice, you can connect a computer or a tablet to a D-Star radio to send and receive data. This data transfer is very fast and efficient, but D-Star is also quite proprietary. Yaesu, another Japanese company not to be outdone, developed their own digital voice capability called System Fusion. This mode is growing in popularity because fusion-capable repeaters are much less expensive than D-Star repeaters. The commercial land mobile radio world has had a digital mode called DMR, or Digital Mobile Radio, for several years. A couple of years ago, enterprising amateur radio operators figured out how to repurpose the commercial DMR radios for use on the amateur radio bands, primarily the 70-centimeter band. DMR has a very low cost of entry since there are so many commercial DMR radios and several manufacturers have leveraged the amateur radio marketplace. DMR is the fastest growing digital voice mode. Unfortunately, at present, D-Star, System Fusion, and DMR are all incompatible with each other. So what digital voice capability should you purchase? Whatever the majority of the amateur radio operators are using in your area. In the Tooele area, DMR is the more popular, but it isn't very popular actually. There are also now on the market inexpensive hotspots, which act as a kind of a repeater at your house. A hotspot is connected to the internet and can be configured to be a D-Star hotspot, or a Fusion hotspot, or a DMR hotspot. Using a hotspot, you can then connect directly through the internet to various conference rooms or internet-connected repeaters. Amateur radio operators have also taken advantage of the fact that some of the Wi-Fi channels are also amateur radio frequencies. Special software has been developed for ubiquity and link-sys routers that allow us to build very robust private networks. FCC rules allow these commercial devices, when used as amateur radio equipment, to have better antennas, more power, and better error correction. Amateur radio high-speed mesh networks are being built all over the world, and we're in the process of establishing one of those networks in Tooele, which will eventually be linked up with an extensive mesh network along the Wasatch Front. It's called a mesh network because as more Wi-Fi routers are joined to the network, they form a self-healing, multi-path network, so that if one node drops out, data will automatically be routed in a different way. Phase shift keying, PSK, remember the term phase shift keying, is a very popular keyboard-to-keyboard protocol and comes in many flavors. On the HF bands, PSK31 is very popular and often gets through when voice emissions can't. On VHF and UHF bands, high bandwidth PSK modes are available and are often used for emergency communications, as they make it very easy to transfer files of information from the transmitter to the receiver. When supporting a Red Cross shelter, for instance, quite often lists of needed supplies have to be sent to a central location for fulfillment. It's a lot easier to enter the needed supplies into a file and send the file than it is to read it over the air and have it repeated back. IRLP and Echolink are two more digital modes that take advantage of the internet using a protocol called Voice over Internet Protocol, or VoIP, VoIP. IRLP, or Internet Radio Linking Protocol, is a method of using the internet to link repeaters together. The 449.425 MHz repeater, for instance, is connected full-time to the Western Reflector in Las Vegas, Nevada. More than 50 other repeaters in Utah, Arizona, Nevada, and California are also connected to the Western Reflector. This network is very popular with RVers and truckers traveling through the area. Echolink is a similar but newer application. There are Echolink apps for your smartphone. Once you register with Echolink, proving that you have an amateur radio license, you can then connect to thousands of other Echolink users or repeaters around the world. I often use Echolink to talk with my son in Ohio. A local trucker who often drives a route through New Mexico, Arizona, and Southern California will use Echolink on his smartphone to connect with an Echolink connected repeater in the Salt Lake area to talk with his ham radio friends in the area. So how do you find these repeaters and VoIP services? The internet is your friend, so is your smartphone. I have an app called RFinder on my phone. It uses the phone's GPS to know my location and then shows me the repeaters close to me arranged by distance. It's a very useful app while traveling. Amateur TV has been around since TV was invented. It's primarily all analog TV transmitting on the upper analog UHF TV channels, although it can be used on any UHF and higher frequency. Amateur TV enthusiasts have been working on a non-patented codec for amateur TV, so we can move TV into the digital world as well. Along the Wasatch Front, there are 3 amateur TV repeaters, and they are quite active. This concludes the video on digital communications, a fast-growing and fast-changing facet of amateur radio. There's a lot of great digital options available and much, much more to come. As usual, if you have any questions or concerns, please note them for discussion in the next online session or email them to me at rolandksmith@gmail.com. We'll see you online.